All right, statistics folks, we're just going to do a few practical calculations here to try and better understand the sampling distribution of the mean and how we can use it using a z-distribution. And inside of all that is where is implied the central limit theorem. So hopefully you have a large enough sample size that our sampling distribution of the mean is approaching the normal distribution. That'll give us confidence that we can use the z-distribution so that to come up with our answers, to find what the proportions are above or below a particular mean. I know that all sounded like Chinese, but let's just jump in and do a problem, okay? Okay, so here's a situation. We have a population that has a population mean of 27, and it has a standard error of 3.2. What that means is that the standard deviation of all of the possible sample means that you could take from this population, all those possible sample means have a standard deviation of 3.2. Also, because the population mean is 27, that means that the mean of all the possible sample means is also 27. Okay, so now that we know that information, we can answer this question. We can say, what is the probability that just one sample, that you take a sample from the population, you take one sample from that population, okay, and what's the probability that that sample from this population is going to have a sample mean larger than 30, okay? Because you could take a sample and it could have a mean of 25. You could take a sample, it could have a mean of 17. You could take a sample and it could have a mean of 52. You could take a sample and it could have a mean of 27 or 26 or 27.5. There's lots of different possibilities because there's lots of different possible samples. So when you take a sample, isn't there a chance that that particular sample will have a mean that's larger than 30? Well, we can find out the likelihood, the probability, the proportion of samples that have a mean larger than 30. And we can use the z-score table to do that. Here's how we're going to do it. We are going to use our trusty old z calculation. Now, the z calculation that you remember looked like this. Z is equal to x minus x bar over standard deviation, right? You recognize this calculation. Well, I hope you recognize this z calculation, but we used this z calculation back when we were dealing with one sample, back when we were dealing with observations. So the data that we had, each one of those numbers was an observation from the population. Now we're not dealing with observations, we're dealing with sample means. Each one of our observations is not an observation from the population. Each observation is a different sample mean from all the possible sample means. Okay? So, here's how we're going to change it up a little bit. Instead of plugging in an observation, we're going to plug in a sample mean, because that's what we're dealing in now. All of our numbers that we're dealing in, our list of data, are all possible sample means. Well, all of our conceptual theoretical list of data are all sample means. Okay? Now, we are no longer dealing in a sample mean, we are dealing in a population mean. So we're going to have to put mu here, and the standard deviation that we're dealing with is now the standard deviation of all the sample means. We have a special name for that, right? It's called the standard error. So we're not going to deal in S anymore, we're going to deal in standard error. And so now our calculation is going to be x bar minus mu divided by standard error. Now I want to remind you that standard error can also be written as the standard deviation of the sample mean, right? So we have x bar minus mu over standard error. Okay? So let's go ahead and do this calculation using this information. In order to identify, it says, what is the probability? Well, how have we been calculating probabilities up till now? We've been using the z-table, right? We could also use the empirical rule to approximate, but we're not approximating here. We're going to use the z-table, and we're going to calculate a z-score. So our z-score, in this case, is going to be equal to the x bar that is given to us. And in this case, the x bar is 30, because we're trying to investigate the probability that an x bar, a sample mean, is larger than 30. So we're going to put a 30 here. Minus mu, and that was given to us in the problem also. The population mean is 27. Minus 27 divided by the standard error, and the standard error was given to us, that is 3.2. Divided by 3.2, and so now we are going to plug this into a calculator. Grab a calculator here, and I'm going to do 30 minus 27, which is 3, divided by 3.2 gives me 0.9375. Now I'm going to round to 2 decimal places because I am using a z-table. Okay, so I'm going to have 0.94. And so now I'm going to go look up 0.94 in a z-table. Why don't you pause the video, get your z-table out, your normal cumulative or your standard normal cumulative probability table, and you look up what the probability is on 0.94. All right, so I got my z-score table here, and I'm going to go to 0.94, and I see 0.8264. 0.8264. So this gives me a p-value of 0.8264, right? But now, I want you to remember something about these this standard normal cumulative probability table. This z-table, all of the probabilities in here are less than probabilities. They're all less than. But this question is not asking us a less than question. This is asking for the probability that we'll find a sample mean that is greater than 30, not less than 30, greater than 30. And so, since this is a less than 30 proportion, we need to subtract it from 1 to turn it into a greater than, right? So we're going to do 1 minus 0.8264, which would give us 0.1736. 0.1736. And so, the answer to this question, what is the probability that a sample from this population will have a sample mean that is greater than 30? The answer to that question is 0.1736. We could say it as a percent. We could say there's a 17.36% chance that we'll take a sample and get a sample mean that's larger than 30. Okay? Let's do one more example. All right, here's another question. Here's another situation. We have a population that has a population mean of 100 with a standard error of 15. Okay? So, what is the probability that a sample, some random sample that you draw from the population, one sample, you draw a sample and you enter all the numbers into a data package, into Excel or something, and you find the mean, the sample mean, and the sample standard deviation and some other stuff. Well, what's the probability that the sample mean that you find with that set of data, what's the probability that that mean will be less than 80? Okay? And the way we're going to be able to do this is we are going to identify a z-score associated with 80. We're going to put 80 in for x bar in our formula. We're going to subtract the population mean 100 and then divide by the standard error, which is 15. So z is going to be equal to 80 minus 100 divided by the standard error 15. Go ahead and calculate this in your calculator. Okay? I'm going to grab a calculator here. And I'm going to do 80 minus 100. It's going to give me negative 20. Divided by 15 is going to give me approximately negative 1.33. And I'm using a z-table, so I'm going to go to 2 decimal places. And now I'm going to grab my z-table. And now we want to look up this z-score, negative 1.33, in the z-table to find the probability proportion, to find the p-value. All right, so negative 1.33, and it's looking to me like 0.0918. P equals 0.0918. Now, this is a less than proportion. And guess what? The question is asking, what's the probability that a sample from this population will have a sample mean less than or equal to 80? So this is our answer. This is a less than proportion. The question is asking for a less than, and therefore this is our answer. So the answer is 0.0918. And that's it, okay? So as you can see, the problems that we're going to do in this section are actually things that you already know how to do. You already know how to calculate a z-score. You already know how to look up a p-value. You already know what to do when it's a less than or a greater than or a between problem, right? So this is stuff that you already know how to do, so you should be just fine, okay?